Hello, welcome everyone to our final presentation for our senior project. We are the Mood Meteor Maestros. My name is Andres Martinez. I am the project manager.
I am Manuel Nunez, the Scrum Master.
And I'm Jonathan Mesa, the front and back end developer. So we're now going to cover our individual responsibilities throughout this project.
So I handled parts of the visual model, and I also contributed to the front end and back end development, implementing our app.py, the JavaScript files. I defined the website style. I worked on using the user input workflow, and I also handled input conversion for model classification, as well as hardware acceleration with my GPU.
I primarily also worked on the visual model. I led the EDA on the visual model dataset. I contributed to front-end development by primarily implementing HTML through both the homepage and the results page. And lastly, I created the ensemble model as a means by which to combine the predictions of both our visual and audio model to create and consider complex emotions.
I handled all aspects of the audio model, which includes the exploratory data analysis, pre-processing, training, and evaluation. And I also contributed to the front-end development, which includes formatting on all pages. And I worked on displaying the graphical elements of the model output on the pages where that is applicable. So now moving on, we're going to go to our code walkthrough.
So for our project walkthrough, we're going to first dive in and talk about the model architecture for both the audio and visual model. Then we're going to talk about the training loop for both audio and visual models. Then we're actually going to walk through a live demo of the website utilizing both models, first at the homepage, then to the user input workflow, and lastly to the results page. And finally, we're going to talk about our insights such as successes, shortcomings, and future developments.
Great. So onto the code review. So we're first going to talk about the visual model that was ultimately implemented. We can see an example of the data used to implement this model below, where each row has its corresponding emotion, an array indicating the pixels corresponding to the, image in question. And lastly, fortunately, the dataset also came with a usage label, which assigned either a training, testing, or validation label to each row, such that there had to be no pre-processing involved in splitting the data accordingly and making sure that each class was equally represented in one of the three classes. We lastly print the shape, which I just reviewed, being composed of emotions, pixels, and the usage label. So one thing we did to start off the visual model was to assign and store the testing, validation, and training data within variables, such that we could then train our model. Here we have an example of the images used to train the model. Notably, Samuel L. Jackson comes out, which is great. We then talk about the actual model architecture. Notably, the model has a lot of convolutional layers, I think 3 layers exactly. And these convolutional layers are tasked with extracting features which are very salient and indicative of the class that the emotion showcased in the image corresponds to. We finally have dense layers and dropout layers to further narrow down the accuracy of the prediction. And lastly, we have a softmax activation function, which assigns the probabilities of each emotion present in the image to the final output. Here is a display of the architecture I just commented on. And lastly, we have a training process, which involved 30 separate epochs with an accuracy, or a training accuracy, I should say, of 75% and a validation accuracy of 57%. We have 2 graphs that kind of gloss over this process, namely the accuracy versus number of epochs graphs, which you can see the validation accuracy increase up until it starts plateauing around epoch 20. And we also have a graph showcasing the progression of loss during training, with loss steadily declining and eventually plateauing, as did validation beforehand. We have this confusion matrix, which, as we can see, is shaded very strongly throughout its diagonal, indicating a model that is accurate. And we will now move on to the audio model.
So the audio model functions in much the same way. It just covers the aspect of audio modality. So here we can see one such audio file that is processed. Reading the files was proven to be a bit of a challenge because they're labeled based on their file name rather than any provided aspect of them. From here, though, the convolutional neural network does not prefer to handle raw audio data. Instead, we first turn the data into a spectrogram, and then from there we turn it into a MEL spectrogram, which is the preferred way to pass audio data through a convolutional neural network. From here, we do some standard steps like creating data sets and data loaders so that the convolutional neural network can process these things. It should be mentioned that the audio network is developed in PyTorch, while the visual network is developed in TensorFlow. But going on now, we can see the audio convolutional neural network, which similarly includes convolutional layers followed by pooling layers, which extracts features from groups of pixels and then normalizes them, followed by some fully connected layers, which convert this data into a decision, which is one of the 8 classification emotions that the model is classifying the data into. So from here, we have the training steps and the evaluation, and we can see that from the evaluation, the confusion matrix similarly provides a long diagonal or a dark diagonal, which is what's desired for high accuracy. And we can see the ROC curves for each individual emotion as it's classified. This is desirable and proves that the audio model is working as intended. So moving on now, we are going to go to the app.py and read input.py files.
So our application stack is composed of 2 main layers: the front end, which is what users interact with, and the back end, which does all the heavy lifting of data processing and model inference. So for the front end, let's begin with just the HTML, CSS, and JavaScript. The HTML lays out the structure of our web pages, creating forms where users can record their videos. The CSS then steps in to provide style, ensuring our application is visually engaging and responsive to different device screens. And lastly, the JavaScript adds interactivity to the front end, managing user inputs, video recording, and dynamic display of results. And now onto the backend, our app.py. We have a robust backend built with Python and Flask. Flask is a light web application framework that's perfect for our needs, and it allows us to basically create a RESTful API that our front end can communicate with. And when a user records a video on our website, the JavaScript sends this data to the Flask server using an HTTP request. This is where the integration magic kind of happens, and this is where Flask takes over, receiving the video data and prepares it for processing. It then calls on readinput.py. There is basically where the data processing kind of starts, and the video is split into frames for visual analysis and an audio stream for vocal tone assessment. And we use specialized Python libraries to handle this. And next is our deep learning models, which are executed in the backend as well, using pre-trained convolutional neural networks that Manu and Mesa described. We analyze the extracted frames and audio to predict the emotional state. And these models are designed to interpret complex patterns and provide a statistical breakdown of detected emotions. And once our models have done all their work, Flask then collates the results and sends them back to the front end as a JSON response. And JavaScript then takes this data and updates the web page to basically present the results to the user in a series of intuitive charts and graphs, allowing them to understand their emotional breakdown.
Great. So now we're going to move on to an actual demo of the website, which is already running locally on my device. So we start off with the homepage. The homepage first allows the user to start recording and actually have the models decipher their emotions. But before then, the user is free to continue scrolling to get a better idea of the service that it is the website offers and how it actually works. So how it works is essentially first, the user records a video, sends it back to the backend where our AI does the process of deciphering their emotions, both basic and complex. And then ultimately an output is provided through which a user can discover their emotions. We provide a quick example demo here so users can further familiarize themselves with how our website functions. We have, for example, a video where I myself am looking and sounding rather angry. I'll play that now. We explain to the user how we divide this input into 2 contexts, namely a visual and auditory context. The visual context is composed of a series of screenshots taken every so many frames, whereas the audio context is simply the audio file stemming from this video in a .wav format. We then showcase predictions of emotions for both contexts. Since the video does in fact contain a user, that being myself, who sounds and looks rather angry, we have both models predicting a high level of anger and also fear, perhaps, in both contexts. We then consider complex emotions in both contexts by combining basic emotions within a single context. For example, contempt has a high score in the visual context, given anger and disgust are both rather notable in the recording. And the same goes for the audio model, where contempt also finds itself to have a very high score. Lastly, we combine emotions across both contexts. For example, we'll consider angry within a visual context and disgust from an auditory context, which will also showcase a high level of disgust in a combined emotional complex. The home page also showcases Plutchik's wheel, which is what's used to decipher complex emotions, and it explains to the user how exactly basic emotions are combined to provide them with an interpretation of their complex emotional expression. Lastly, the homepage also comments on the applications of our service, namely mental health monitoring, enhanced customer service, and educational tools and e-learning are three, applications where we think that a detection of emotion could truly provide help. Now we'll actually start recording and demo the changes. We'll record a video now. I'm so mad right now. Where I'm also sounding and looking rather angry. We have the option to either send this video or record another video. We'll go ahead and send this video. Now, there's a loading screen that the user is usually on, but since I myself am hosting it locally, I can go on the server and I can showcase the log messages being shown on screen. We can see how the conversion was successful. And soon enough, these two faces, which as of now correspond to the last recording, are going to be substituted in by the recording that I just recently took, as well as the .wav file. This should take approximately another 50 seconds. Once that occurs, however, we should be out of this loading screen and we should be showing the results page. So now that we have finished processing the emotions, the loading screen changes into the visualize, or otherwise known as the results page, where we have f-strings displaying a summary of the emotions conveyed by the user, a video where the user can once again play back what it is they submitted as input. We have the visual predictions as were shown in the homepage for the example demo, accompanied by the audio predictions. Audio did in fact detect a high degree of anger, whereas the visual predictions detected anger as well as fear. We then have complexity for both the audio and visual complex, and we have complexity for the combined complex. The user can then go back to the homepage or they can record again. I'll go back to the homepage in this instance. We'll now talk about the insights, mainly the successes, failures, and future work concerning our project.
So as for successes, we started this project very early, leading to us having plenty of time to accomplish everything that we wanted to. We worked on it in a timely manner, dedicating time to it in a scheduled, orderly fashion. And we also covered all of our individual responsibilities quite well. Furthermore, we managed to help each other with areas outside of our expertise, leading to us all gaining a deeper understanding of how this deep learning model works behind the scenes. One such area is convolutional neural networks, which is an area that we did not have too much expertise in prior to this project. However, now we could all say that we have a good amount of domain knowledge and could definitely work on a project like this in the future. Moving on now, we are going to cover the failures associated with this project.
So as for the failures, we faced our fair share of obstacles, and the first being our model accuracies. At first, our accuracy of our models weren't always on target, and it was clear that they needed more refinement to discern closely related emotions accurately. But over time, we were actually able to improve them and gain better accuracy. And as for a second obstacle, the front-end development. As for the front end, none of us were seasoned pros, and we were novices of front-end languages and design principles. And it's fair to say that we stumbled through JavaScript quirks and CSS layout issues, learning the hard way that web development is very rigorous.
Great. Lastly, as far as future work, we'd like to keep on enhancing the models, and ideally we'd also like to integrate a lexical component into the recognition and detection of emotion. In other words, aside from considering an auditory and visual complex or context, we would also like to consider what it is the user is actually saying and add that onto the ensemble model that was ultimately used to combine emotions and decipher complexity in a combined context. That said, that is our senior project final presentation. Thank you very much.